Alright, this is Chapter 7, Lesson 5 on three-dimensional figures. Three-dimensional meaning they no longer are flat, planar objects. They have three dimensions, length, width, and height. So this is just kind of a lesson on how to view and how to draw them, which I know is a joke for anybody who knows me, because you know I can't draw. But there are several different ways to look at a three-dimensional figure. There's what is called an orthographic view and an isometric view. An isometric view is looking at the same item directly in a flat way from all three views, like the top view, the side view, and the front view. And then an isometric view is looking at a three-dimensional item like from the corner or from an angle, so you can actually see the depth of it and see all three dimensions at one time. So number one you see is this idea of isometric view. You're looking at it from an angle so you can see. And by the way, a lot of times they'll have this dotted line to show you things that are in the background that you actually can't see. You would not be able to see that line on the back that makes a rectangle on the back of that. But when I look at this and I want to write it into an orthographic view, the three different views, if I were to look at it from the top, if I walked over top of it and stared down flat at it this way, I'd be looking at a trapezoid. So there's one view. That'd be the top view. When I go from the front view, if I'm looking at it directly from the front, it will look like one elongated rectangle. Now you might be able to see some shading differences here where the middle is, but it's just going to look like one big rectangle. And if I looked at it from the side, walking around here, it would also look like a rectangle, a shorter rectangle, but just a rectangle. There are the three views, the top view, front view, and the side view of that three-dimensional item. So if you can take an isometric view of the top, the side, and the front and piece those together into what is a three-dimensional figure, I see from the top it looks like 4 squares, from the side it looks like 4 squares, from the front it looks like 4 squares. So this is just a cube that would be a 4x4 cube, just like that. Now we're looking at an angle so you can actually see where it changes, and there are your three dimensions, length, width, and height. So I have a couple of bonus ones just to look at. If you were looking at this from the front and truly walked right in front of it to look at it, it would simply look like a rectangle. You wouldn't be able to see a curve. If you went to the side, guess what? It would look like that exact same rectangle. But if you walked over top of it and stared down at it, it would look like a circle. So this is what you call a triangular prism. If you looked at it from the front, you would see this triangle. If you looked at it from the side, so you walk around here and look at it from the side, you would see a skinny little rectangle. And if you looked at it from the top, you would see a skinny little rectangle going this way. The three views. Excuse me. You're in a test. These are three views, a top, a side, and a front view. So if I looked at it from the top, it would look like these 8 boxes. If I look at it from the side, though, you can tell there's a shift. These 2 boxes right here are a little bit higher, if that makes sense. In other words, they have 2 stacked up. And from the front, you'll only be able to see, so you think about it, you'd be able to see these boxes and these boxes, which would end up looking like this. So if I piece that together with what it looked like, I would end up drawing, I'm kind of making it a little bit larger than what it really is, sorry. There's your side view. Now, of course, it goes back. So now, once again, you have 4 going this way, and this one is the higher one, so now you can see it from a three-dimensional view where you have length and width and height and all that as all 3 dimensions visible at once.